Well, good morning, everybody. Welcome to our latest CTO Tech Talk over here at Gotham. I'm Ken Phelan. I'm the Chief Technology Officer for Gotham Technology Group. And joining us today is my good friend, Ravid. Yeah, I'm going to put you up to good friend status, Ravid, because I think this is like our fourth or fifth meeting together. And this is one of the few ones that I don't have a drink in. So I'm gonna go with my friend Ravid, if that's okay.
Definitely.
That's all right. Ravid is founder and CEO of Seemplicity. I'm going to let him introduce himself a little bit, and we're going to talk a little bit about the application security space here a little bit. And Ravid's definitely an expert. So, Ravid, why don't you introduce yourself?
Yes, thanks, Ken. First of all, very happy to be here today. I'm Ravid, the co-founder and the Chief Product Officer of Seemplicity. Been in the industry for many years around network security, vulnerability management, cloud security, application security. A lot of experience both on being on a vendor side, but also about being on the practitioner side and suffering from many of the problems we are going to talk about today. Really happy to have the discussion. I have a good feeling it's going to be very interesting.
No, thanks so much for being on. And it is an area that a lot of people are kind of focusing on, sort of the application security problem. And I think there's been an evolution in security, right? We've both been doing it for a little while. Like we sat around talking about security in the late 1990s. We're talking about network security, and even before that, like it was identity, it was this. And I think application security is really to the forefront today. And I guess, I mean, but we've been writing software, whatever, my whole life. Like what is it about software in today that's made this like kind of rise to the top all of a sudden? Is it changes in the way software is done? We're just getting smarter about it. Like is there, in your mind, like a reason why applications at the forefront right now?
So I think there is a lot of things that are happening on the same time. So I think first of all, as opposed to many things in the past, software today is not kind of written. It is more assembled together from different pieces. You get some of your infrastructure from and services from your cloud provider. You get some of your code from open source libraries or third party that you OEM. You get some of your distribution and kind of customer facing from service provider. So there is a lot of moving parts in the software, which are not all of them are completely in your control. But at the same time, the fact that it is assembled and not written from the ground up actually allows you to create more application and more code much faster. So actually what we are seeing is that we are seeing that the world of application is being transformed from some monolithic platform that you built yourselves from the ground up, including all the infrastructure capabilities, all the networking, all the operating system, and all of that, to a point that you actually assemble different pieces. The assembly itself is also code, infrastructure as a code, configuration as code, and so on. And therefore, what we are seeing is that the software become a good mixture of many small components, which is very good that it allows you to run much faster, okay? But at the same time, it makes it more complex to control and verify and trust from a security perspective, all those small moving parts. So I think that what we are facing these days is take how the software development has changed together with the digital transformation, that today there are more online transactions than there are physical transactions almost everywhere. Then all of that together is what gets us to the point that software is probably more important than ever. There are people that says that software will eat the world in one way or another, because it's kind of taking over almost everything that we were previously doing face-to-face. We are doing that today with the software. So I think the combination of all of that is what gets us to this point, where you have a software, it is more complex than ever. It is a lot of small moving parts, and you need you and the security team need to secure that as we go along.
I think we're just writing a ton of it. So I mean, you were kind of saying this, but the amount of software that's been developed, that is being developed, and I think all of these technologies sort of lower the bar to what even is development in terms of assembly and scripting and who's writing code and how they're writing code and how many people are and also I think most companies have evolved in terms of technology. Like I've talked to people in large finance companies, and they're the first to admit, like, we're really a technology company that happens to be in finance. Like, we have so many software developers. Development's the main thing. Like, codifying business intelligence into computing languages is the main thing people do, right? There's just a ton of code out there, and to me, it's also, I think we're kind of paying for this technical debt. Like, we've been writing code for so long now, and it's just been dragging this anchor behind. I mean, it seems like a very, just the scale of the problem seems immense. I mean, isn't that part of it just daunting, or do you think is there a way to get in front of it?
I don't know if there is, so I think there is different ways to kind of get ahead of it. I think that there was discussions about, I think there was a discussion about shift left and actually get security involved much earlier in the development process. I think that there is a lot of great success over there, but I think that as a market and as practitioners, we kind of hit some limitation of those capabilities of shifting left. So shifting left is good because it allows you to identify security problems earlier in the process, and what makes it much cheaper and easier to fix. But at the same time, that complexity and that relying on different parts of the software that come from different components, from different infrastructures, actually put you in a position that even if the system is already in production and not being changed and not being developed, it's getting old and getting aged and accumulating technical debt and accumulating vulnerabilities and accumulating known problems. So actually the shift left doesn't take care of everything that happens not as part of the development cycle. And if the system is just there in production and not in a kind of a overly developed cycles, but just in maintenance cycles, then it doesn't help a lot. So shift left is good, and it was doing a lot of and I think that we are starting earlier today and preventing a lot of problems. But I think that should also be additional motions. And I think that those additional motions are around how we look on making security as a standard track of software development. So if you talk to my developers that sit right behind me, and I will ask them what kind of issues you have in your Jira, they will tell me I have bugs and I have features. Okay, I would want to get to a point that they have bugs, features, and security problems. And each and every one of them is a backlog that is being managed by them, because the same way that they kind of consider what it is that they are putting on the same sprint for features or for bug, we will want to have them also decide what they put in terms of security, because security is not different from a bug. It's the pure quality of the system that you have created. So I think that a lot of what we need to think of is how to not just have the security issues being a security team problem, but how to have security issues as part of the day-to-day of the developer, of the engineering manager.
Right. Well, it goes back to, like, basic code quality stuff. I think I kind of want to talk through some of these issues with you in terms of, so I also think that's an area where we as cyber practitioners haven't necessarily been super strong, which is in working with the developers and doing that stuff traditionally and that kind of stuff. So I think that's an area we have to grow in. But like whatever, I was doing this morning. I was thinking about code reviews and stuff, and I was writing code in the 80s for a point of sale system, and I had to sit and write the code to basically turn a modem into a credit card approval process. Like, so go to your PC modem and turn it into an old school Zon and call up and do the thing. And I'm writing this code knowing full well, like, no one's going to read this code. And I'm like, what exactly is stopping me from sending an extra 1/10 of a cent of every transaction that goes through this library that I'm going to publish off to some, Cayman thing, which might be why I have such a great job running CTO of Gotham today, because I maybe have a Cayman account. But the code reviews don't always happen. These things don't always happen. And it's not just a function of like CVEs. It's just a matter of looking at this stuff. I mean, so I think let's talk about that process, right? So, like, for instance, we used to do like code reviews and like even like active dynamic scans. Like, we used to do that. So maybe you could like explain to you like sort of the evolution, like, is that, are people still doing active dynamic scans? Do those still work? Like, what's the difference? Maybe you can help educate a little bit, like, between an active and a dynamic scan.
So I think that, yes, I think that the world today is kind of is evolving. So, for example, traditionally people have started from doing more, as you said, code reviews or static code analysis, which means that you're actually reading the code and moving through the lines and trying to identify flaws or unhandled part of code or unhandled part of input and so on and so forth. It then later kind of moved into more dynamic testing. And I think the difference between static code analysis and dynamic testing is that dynamic testing actually allows you to see what happens if. So for example, you have an API call, you send all the possible permutations that are out there. You see that there is a field that is a dollar amount, which means that the application is expecting number. What happens if you are sending a negative number? What happens if you are sending characters? And a lot of that actually test that system more as a end-to-end result. We don't just look at that specific function that we wrote right now, but we actually look on how all the components are working together. If I put a specific input, what will be the output that I'm getting? Okay, so we move from static code analysis to dynamic code analysis. And today there are movement to newer techniques, for example, interactive application security testing that combine the two to some extent, trying to run dynamic testing, but through looking on the code and actually try to kind of reverse what good testing will be. And all the way to really runtime self-protection, such as API tools that sitting in front of your API gateway actually learn through the usage of legitimate users how the application should work and actually block everything that doesn't look legit from that aspect. So there is a lot of involvement, but this is all only related to code that you wrote yourself. At the same time, we have all the things around software composition analysis and supply chain analysis of all the libraries that you're using and all the components that you're using, that they are protected and they don't have vulnerabilities or don't have any meaningful problems. So I think there is two parts: the part that you analyze and secure your own code, and the part that you analyze and secure code and infrastructure that you are using as part of the services that you are getting from your cloud providers or the way that you assemble your platform. And I think one of the main importance part is the piece that put everything together. So it's your CI/CD that actually take your code, the things that you assemble, and create the artifacts and put that together. Because if someone will penetrate your CI/CD process, actually he can bypass any testing that you were doing before and any testing that you are doing after, and just inject those 10 cents to Cayman wherever he wants, even though it was actually reviewed by someone. So I think there is a lot of secure the thing you do, secure the thing you use, and secure the things that connect those together that we actually need to look at.
Yeah, I think it's and again, it's on all this complexity, right? All the different elements of the libraries, the different code sets, what you're working in, how you're working in with the languages. And I think it's, from my perspective, trying to guide customers on this application journey. There's so many vendors claiming to do everything. And in my mind, how can you possibly do everything, right? How can you be like an expert at GitHub and an expert in cloud and an expert in, so I mean, in your mind, like, how do you kind of look at all of these elements? And also, I think customers are challenged because I think one of the challenges they have is, certainly in the large customers, they might be doing everything, right? It's a scope problem, right? They have lots of different kind of development, a lot going on, lots of different business units for lots of different reasons. So, how do you get that horse back in the barn? How do you even evaluate competencies across all these different kind of platforms?
So it's a great question. I think that us as a security guys will want to have the best of breed on any aspect that we want to secure. We want to have the best of breed for our container scanning and the best of breed for our code scanning, which might be different tools. and the best of breed for our infrastructure as a code canning, which might be a third tool, because we want to make sure that we secure our code and application in the best way that is possible. At the same time, the developers, the fixers, the people that actually need to make those fixes, they kind of don't care that we scan with 3 or 4 different tools. They just want to get one backlog of security issues, prioritize in between itself. They don't care which tool has identified that. They don't care that they scan for the same thing and they have like 20% of the duplicates. They just want to get a simple backlog. I have features, I have bugs, I have security issues. It's all the same. I don't care how it was produced. So I think that on one hand, we want to have the best of breed for everything. At the same time, we actually want to represent for the rest of the organization a very unified, coherent backlog of security issue to reduce the friction and to make security as part of the day-to-day work, and not that special case that every 3 or 4 days we just need to go over the backlog again because another tool was running another scan and produce a whole set of different results. So I think that organizations need to find the right balance between discovery, scanning, and identifying problems and how many tools they're using for that, and at the same time, how they're utilizing those results and get that at the hands of the people that can actually fix that, because the security team cannot fix that. The security team cannot change a code. The security team cannot patch a container, okay? And therefore, we kind of need to think how we help the fixers to work with the results of our security tools in order to secure those applications. And if you're able to do that, if you find that thing in the middle that does it very well, then yes, you can adopt best of breed tools for any small piece of your organization, given budget, given constraints, but it doesn't care because it's fully transparent for the fixers themselves. They just get a backlog of security issues that they need to address.
Yeah, but it's a sort of a signal to noise ratio too. I think as security practitioners, like we evaluate these tools, we look at them. It's very impressive. Like you come and do a POC and like, oh, look, this tool found 1,000 things, like so many big problems, but on some level, the developers look at it and go, these can't all be real. They start to, again, they start to feel like it's noise, not signal. I mean, how do you know that you're prioritizing the right things and giving the right work to your teams? Because obviously that's a valuable resource, right? Development time is a pretty valuable resource. So how do you kind of make sure it's not just all splash?
It's a very interesting question, because we, the security market, okay, as a market, kind of trained ourselves to prefer quantity. If you were doing a POC for 2 scanners, if one would give you 100 results and the other one will give you 20 results, you don't know if the second one is just prioritizing better or it has lack of coverage to the 80 that was discovered by the other scanners. So to some extent, we as a practitioner incentivize the vendors to find more. Okay, we kind of checking them by how much they find. And that kind of creates a spiral of they find more, we need to handle more, we cannot handle more. So we need to better prioritize, and then we better prioritize, but it's still not enough as they get to the fixer because there is a lot of noise for many different tools. I think one of the best ways to reduce signal to noise ratio or to improve that ratio is to stop thinking about problems and vulnerabilities and risks and findings and start thinking about remediation items. Start thinking about actionable items that you need to do. Because, for example, we talked about technology debt. If you didn't upgrade your Java library in one of our applications for a year, you probably accumulated anything between 80, 120 different vulnerabilities. Now, the solution for all of them is pretty much the same. Upgrade Java to the latest non-vulnerable version, okay? And therefore, we took like 80 or 100 different vulnerabilities and different problems and make of them one remediation action items. And that's a very good way to improve dramatically the signal to noise ratio, because we are actually starting to train the organization to think on actionable things rather than a long list of problems. On top of that, you can actually start doing prioritization, because one of the interesting stories I had with one of my one of the person I was working with, he was telling me a story. I spent a whole day to analyze a vulnerability presented by one of my tools. I got to the conclusion that it's a false positive. Okay, it took me a day. So I was so proud of myself that we don't need to fix that. And then an hour later, I got a different one, which need to be fixed, and it has the exact same solution as the one that I marked as a false positive. So I kind of spent a day, okay,
Right.
just because I didn't realize that both has the same solution. So the idea of moving towards a solution-oriented discussion, remediation item-oriented discussion, rather than vulnerability or a finding, will actually do magics in the ability of both the security team and the fixing team to scale up.
Yeah. I want to talk about the operationalization of this for a second, because I think that's one of the challenges, right? Because you're kind of saying like we need the developers to do the fixes. Developers, are kind of live in a different world, not just in IT, but sometimes like even in like they report into the business units. They don't really, like the governance is different, the structure is different. I mean, do you see this as sort of a challenging the way we look at the governance of the organizations? Like, how do you kind of approach this from a political perspective to make sure? So I think a lot of my uh, practitioners on the cyber side are like kind of approaching this kind of gingerly because they know they have this problem, but they really don't have the clout to kind of work it. So I mean, how do you kind of approach this on a board level, I guess?
So I think at least my most basic observation is that no one wants to ship an unsecure application. Okay, I don't
Right.
think that developers want to create an unsecure application or application which is easy to attack. I think that what happens is that um, security in general is not accessible enough for the developers, for those people, in a way that they can actually have that as part of their day-to-day. There was a CISO that once told me, you know what is my biggest problem? My biggest problem is that I always 3 days late for the sprint plan. So after the
Yeah.
developers and product managers agree what they are going to do in the next sprint, I come 3 days later with the critical things that I need to be fixed within this sprint. If I would have come 3 days earlier, that's probably reduced the friction dramatically. So I think
Right.
that while developers want to create a more secure software, want to deliver a better software, the way that the communication collaboration with the security tools, with the security teams, does not align in a good way with how the developers work. If we will be able to get to a point that a security issue is just another bug, okay, that need
Right.
to be prioritized with other bugs, I truly believe that the organization will want to fix more of that and will fix more of that. So it goes throughout talking about action items rather than problems, reducing the noise, reducing duplications, make it more expected. So, for example, a typical development organization that work in a 2 weeks sprint will review its backlog of bugs every 2 weeks before they start the sprint. Can we make sure that the latest 10 or 15 findings that we want them to fix in this sprint are ready for them when they are doing the sprint planning? Not in spreadsheet, not in some PDF report, in Jira, but only those 10 or 15. So they
Right.
don't need to go and go through all the history of all the vulnerabilities ever identified, but just the
Right.
10 that we want them for doing this week. As we will go that and we will make it, we will think about the fixers in mind as we build our processes. I think that we'll see a great improvement in handling those, because it will not be that we have feature bugs and every once in a while we have security issues that are heavy lifting. We will have features, bugs, security issues, and the engineering manager, the product manager can take responsibility on making sure that his software delivery is more secure.
Right. No, that's like a great idea. I mean, that motioning from like just giving like piles of like problems and CVs and into like the actions you want, I think sounds like a great way of getting that. And maybe, I mean, maybe you talk a little bit about, so I mean, that's not what I see regularly. I mean, is that something that you guys have worked out, Simplicity? Like, how does that magic happen of getting into those actionable items? Because there's just so many different tools. We've talked about it. Everyone's got multiple tools in this space. Like how does that come together? That piece of magic.
So yeah, we in Simplicity created a platform for remediation operations, and we look at that, and it's not, we could have told that it's a risk management platform or exposure management platform, and we choose to talk about remediation operation because we believe that the part of productivity is in the communication and collaboration between the security team and tools and the fixing teams. You can think about it in a way that you cannot think of a software development team that works without a Jira. Okay,
Yeah.
you cannot think of an IT teams that work without ServiceNow. You cannot think about a sales team that work without Salesforce. But only the security team keep working in some data spread around multiple different tools, spreadsheets, status meetings, and all of that. So we kind of thought about that the way to improve the productivity is to actually to look on how we can create that single source of truth that also have a lot of communication and collaboration automations that make the workflows and processes much better. So we built the remediation operation platform, which is essentially unifying all the findings and remediation items data from all those different tools and create automated workflows to get those findings at the hands of their fixers. Okay, and we are doing that for application security, but we are doing also that for vulnerability, the traditional vulnerability management, for cyber asset management, for external attack surface management, for all the different exposure domains, where the idea that it is in mind is that the security team will put into the platform the way they think about prioritization, the way they think about their SLAs, the way that they think about how they want stuff to be remediated, and then allow the remediation teams to consume the data in whatever way they want. They want to get tickets to Jira or ServiceNow, they can. They want to get alerts on Team or Slack, they can. They want to consume it through an API to their own dashboard, they can. They want to come to Simplicity, review their backlog, and decide what they're going to fix on the next sprint, they can. The security team cannot scale to do that if they have 4 or 5 tools, and for each of them, they need to kind of serve the data a bit different to each development team. Having Simplicity in the middle actually take that information, allowing the security team to apply a very central policy, risk-oriented specification. It removes all the duplication. It transforms from findings to remediation items, but then allows the fixing team to consume that remediation data in any way they want, no matter what was the original tool that was actually doing the scanning, and no matter where the remediation teams want to consume that. And that's what actually helped to make those fixing teams accountable, because they have full access to whatever they need, however they want it. And that reduces a lot of the friction and allows them to kind of start to take ownership on how to operationalize those security findings or security backlog.
That sounds like, it sounds like a really great endpoint to get to. I mean, I guess, again, I think I just maybe dumb this down for a second in terms of like a lot of my customers, like I said, they're just starting in this space. They know they've got these problems. There's a bunch of different tools. Like, if that's the endpoint I want to get to, which sounds fair, like what are the steps? Like, what is the low-hanging fruit? How do I start time to value? Like, what should a customer who's starting to get involved in this space, who's starting to figure out, I got this pipeline problem, I have the secrets problem, I have how do I get into that space rationally? Like, there are small beginning steps. Do I start with something like, what do I do? How do I start this process?
It's a great question. I think the first thing that you need to do is to basically set up your program, because there is no tools like that together in the market. A lot of how security teams are prioritizing things is tribal knowledge rather than a defined program. Okay, how quickly we need to fix things is more a kind of agreements or some soft kind of commitments, rather than an SLA, which is agreed with your technology partners of really critical things we will try to fix within a couple of days. Those that are not that critical, we will need to do it in a month, and all the others will go to the technology refresh that happens once every 6 months. So I would say you have your program in your head, okay? Formalize that. Put that in a platform that allows you to implement that program and start communicating in the organization in a very consistent way, not based on a tribal knowledge, not being changed every time that there is a new security engineer coming on board. but actually a very consistent way. I think that's the first step. Most of the teams have that knowledge. They have a hard time to actually put that in practice, given that they have 3, 4, 5 different tools. Once you did that, then the next step is to start thinking together with your fixing counterparts, with developers, with DevOps, with engineering, what will be the best way for them to consume the results of that program so they can absorb it as part of their day-to-day processes. But I think the first thing is just take that knowledge that you have, that tribal knowledge that you have, and put that in a platform that will make it very, very consistent across all your tooling and across all your domains, no matter if it's a vulnerability management, if it's application security, if it's cloud security, or what have you.
Yeah, I think there's a big concern stepping into a new space like this, that you're gonna pull up the covers and see a million things that have to be fixed. You're just not gonna have time. Like, in other words, like, you want to approach it in a way where the number of things that you're gonna fix and prioritize is rational and can be addressed, rather than you get surprised because you start to look, you get a new data set, and the new data set is like toxic, right? It's all bad news, can't be addressed in any reasonable time frame. I mean, I think there's like a little bit of a slow step in this, just because people are concerned that they're gonna pull the covers off this and see a rat's nest. I mean, is that an experience you see, or do you just feel like?
I definitely see that, but I think that security leaders doesn't need to look at that as I need to fix everything now. They need to look at that on continuous improvement mode. So, for example, one of the CISOs of a very large company that I have met, when they come to prioritize their findings, they said, I want only 4% of the vulnerabilities to be on the highest priority. They didn't define how much, what are those vulnerabilities, but they actually came the other way around. They said, I want to get to a goal that 4% of the vulnerabilities are my highest priorities, and they start playing with different parameters like what is the original severity, whether it's a known exploitable, what is the EPSS rating of that. Once they got to the 4%, they say, okay, that's my goal right now, to be able to fix those 4% in a 2 weeks time frame. And as they got into that motion, they actually said, okay, we now want to move from 4% to 6 or 7%. So they were actually thinking about not, we have so many problems, how we solve all of them, but how I train my organization to solve more of this, and actually look at that as an improvement over time, as look on making the organization more resilient, more remediation oriented, rather than how do I reduce the risk immediately, because you cannot reduce the risk immediately. And more than that, you cannot control what's going on the outside. You cannot control what will come on the next Microsoft patch. What you can control is how your organization is reacting to that. And therefore, many of them are starting to think of how I make a continuous improvement in that sense, rather than I have millions of findings, I don't know where to, I don't have any chance to cover all of that, so I'm not starting anyway.
Right. We're about 35 minutes now. I said probably 35, 40 minutes. So if people have questions, Ali, they can type them into you, or you can open up their mics. I guess, I think it's a challenge right now for customers. If we talk about this being complex, it's a new area, it's a new structure. I mean, do you think, as you look at this problem for a lot of customers, is there money they can recover? Is there waste in the way that they're doing it right now? Or do you think this is just a new spend that people have to look at? Do you see people finding ways to look at this and be more sensible about it? Or are the older tools no longer effective? Like, how do you look at this economically?
So I think there is a lot of economic benefits, but to be honest, one of the things that I always laugh with customers, and it's somewhat a joke. I also always tell them it can be part of your recruiting fee, because one of the problems is that security experts are getting fatigued from doing project management, administrative stuff, of moving reports from one side to the other. So they leave you. You need to recruit a new person. You need to get them up to speed and all the things about that. So I always say, even just making your staff happier in terms of and more effective, having security expert handling security things and not administrative tasks will go a long way in making you more effective. But actually, within our customers, we see a lot of benefit in terms of how many people they need to operate a large scale organization. So assuming that you have, I don't know, organization, one of our customers has about 150 development teams with an exposure management team of 4 or 5 people. How do you operate 150 development teams, making sure that each and every one of them has their own security backlogs every 2 weeks? You probably need about 3, 4, 5 times people in order to do that. And actually putting automation in place will go very, very far in actually returning the investment. And I think that also you actually also need to look at that as part of when you come to build your arsenal of tools, you actually need to think about, I put all those tools that discover a lot of things, tell me about a lot of problems. How much of my budget I put in order to get those things being fixed? Because the fact that you know about them, and we talked about it, doesn't mean that you are able to fix them because you're not the one that's fixing them. So part of your planning should be, there is a budget for discovery, but there is also a budget for making those being fixed. And as you start thinking about it this way, the mathematics of budgetary consideration becomes very, very easy.
That makes a lot of sense. Ali, did we get any questions from the group?
I do not.
Okay, perfect. So, Ravid, is there anything I didn't ask you? Is there anything we had an interesting conversation, but is there anything you or any final thoughts you have about, things that you want to share?
No, I think that again, I'm not surprised by why we are seeing this kind of evolution in the application security area. I think that there was changes in the market. That some of them are technology. We covered that at the beginning, like assembly and cloud. But there is also changes in the way the teams operate. So when you were a programmer 20 years ago and I was a practitioner 20 years ago, there was a different team for networks and firewall. There was a different team for operating system, a different team for application. Today, the typical development team or the typical DevOps team doing all of that, we need also to help them to get the keys to the security domain. Of course, not knowing about all the problems the organization has, but we need to make them self-sufficient also in that area. And I think we need to start about democratizing remediation data, democratizing security data, so people can take ownership on that and not just be fed by the security team, which is always become a bottleneck. So I think there is also a culture change that is involved on top of all the technology challenges that we are facing.
No, great point. Great point. Well, great time spent with you. Thanks so much for this, Ravid. I know next time when you're in New York, I'll see you. But hopefully next time in Tel Aviv, I'll see you too. That would be good too. I'm gonna stop by. Are you in Tel Aviv today? Right, you're in Tel Aviv now. Yes. Soon. Yes. Perfect. All right. Well, have a great day. Thanks everybody for joining. And if you've got any questions, you certainly can reach out to your Gotham rep, and Ravid's available for in-person calls as well. Thank you, everybody. Have a great day.